Well, now we're doing question 35, and we're doing implicit differentiation again. And we've got to find, first of all, we have to verify that this point is on this line. And we're going to do this without writing things down. So first of all, we're going to let every y value be 0 and every x value be -1. So if we let y be 0, that will become 0, that will become 0, and that will become 0, so they're no longer in play. If we let x here be -1, when you square -1, you get 1. So 1 times 6 is 6, and 6 minus 6 is 0. Notice, then that point is on this line because when you install those values for x and y, you get a true statement. Now, for a, we have to find the equation of the tangent line to the curve at this point. So we'll use implicit differentiation. We'll take the derivative with respect to x of every term here. And when you take the derivative of the first term, you just get 2x, or 12x, I beg your pardon. Plus, now we'll hold the 3 outside, and we'll go inside, and we'll take the derivative of xy, and we'll use the product rule. So if we take hold x constant and take the derivative of y, we'll just get y prime. By the way, I'm going to let y prime equal dy dx to save ourselves some notation. Now, we'll hold y constant and take the derivative of x with respect to x, and that's just 1, so 1 times y is y. Now, we'll take the derivative of 2y squared with respect to x, and bringing the 2 down, we get a 4y, and then dy dx, which is y prime. Plus, and now 17y, we'll take the derivative of that with respect to x, and we get 17 dy dx, which is y prime. The derivative of -6 is 0, and derivative of 0 is 0. Now, we'll go ahead and expand this thing, so we get 12x plus 3xy prime plus 3y plus 4y y prime plus 17y prime equals 0. Now, we'll subtract all the terms not containing a y prime from both sides. So we'll subtract 12x, and on the right side we'll get a -12x. This will disappear. Subtracting 3y from both sides, we'll wind up with a -3y. On the left, we'll have these three terms containing y prime. So what we'll do, we'll factor a y prime out of each of those terms. So if I factor a y prime out of this term, we have 3x remaining. Plus, if we factor a y term out of this term, we have 4y remaining. Plus, and if we factor out of this term, a y prime out of that term, we have 17. So, now let's isolate y prime. So y prime equals -12x minus 3y, and dividing both sides by this factor, we get a 3x plus 4y plus 17. Now, let's evaluate this thing for the point -1, 0. So you already know that any value, any term containing a y is going to become 0. So this 3y, that'll be 3 times 0, that's going to disappear. Replacing x here with -1, we have a negative times a negative, which is a positive 12. replacing x here with -1, we'll get 3 times -1 is -3. 4 times 0 is 0, y is 0, and plus 17. So now we get 12 over 14, which reduces to 6 over 7. So let's keep that in mind. So y prime of -1, 0 equals 6 over 7. I'm going to erase. So y prime of -1, 0 equals 6 over 7. Now we use the point-slope form of the line to come up with the equation of the tangent line to this curve at that point. So y minus 0, well, y minus 0 is just y equals 6/7 times x minus a minus 1, x plus 1. So y equals 6/7 x plus 6/7, and that's the tangent line. Okay? Now, let's find the normal line, and for the slope of the normal line is going to be the negative reciprocal of the slope of the tangent line. So that's going to be -7/6. So now we know we'll use the point-slope form of the line. Y minus 0 is y equals -7/6, and x plus 1. Because what value of x takes that to 0? -1 does. What value of x takes that to 0? -1 does. Okay, now let's multiply this out. Y equals -7/6x minus 7/6. And here's the equation of the normal line. There it is, and we're done.